In example 4, we will pretty much summarize everything we've done in this section in one problem. So here we go. It says the g of x function is x cubed minus 27x minus 6. And in part 1, it wants the critical numbers of g. So since the g of x is x cubed minus 27x minus 6, and they want the critical numbers, I'm going to have to find the derivative g prime of x using the power rule a few times. So first of all, derivative of x cubed is going to be 3x squared. The derivative of 27x is going to be just simply 27, and derivative of negative 6 is going to be just simply 0. And this can be factored further to be 3 and then x squared minus 9, which in turn can be factored even more times. So the g prime so far is 3, and then x minus 3 times x plus 3. Because of the difference of squares, x squared minus 9 can be rewritten as a product of x plus 3 times x minus 3. So now, what makes the g prime of x equal to 0? This happens when either the first parentheses is 0, or when the second set of parentheses is equal to 0. Keep in mind that the 3 in front is always going to be a 3, so it's itself cannot be 0, but the x minus 3 and x plus 3 can be 0. That's because of what's called the zero product property, which says if you have a product of 3 things and you want a 0 at the end, one of the things have to be 0. In this case, the first value I get is 3, and the second value I get is negative 3. So those are my first two critical values or critical points. And now the question is, what makes g prime of x undefined? And again, the answer is no possible answer in this case, because there's no derivative on my g prime of x, so there's nothing that makes it undefined. So that's pretty much the end of part 1. We just found the critical numbers. So part 2 says, tell me the places where the function is increasing and decreasing. So to do that, I'm going to draw the line, and I'm going to put the critical numbers on the line. In this case, the critical numbers are negative 3 and positive 3. And make sure you put them always in the correct order. And because this is the first derivative test, I'm going to label it with g prime of x on the side. Next, pick a test value. So pick any test number you want between negative infinity and negative 3. I'd like to pick negative 10 this time. And I need a number between negative 3 and 3. I'm going to pick 0, and I'm going to pick 10 from the interval 3 to infinity. And again, remember the numbers that you're picking are going to go into the derivative to tell us if the derivative is positive or negative. So for instance, take negative 10 and plug it either here or there. It's up to you. It doesn't matter which one you do. They all should give you the same answer at the end. I'm going to use the third one because it's fast. When I plug negative 10 into it, the answer that I get is going to be at the end a positive amount, because negative 7 times negative 13 will be positive at the end. And that's basically it. So now at this point, I can pretty much go ahead and erase the negative 10 and just get rid of it. I don't need to see that. Next, we take the 0 and we plug it into the same expression. When I plug the 0 in there, I'm going to get 3 times negative 3 times positive 3. And at the end, the outcome is going to be a negative number. And so again, that's pretty much it. 0 did the job, so we're done. We can erase it. And finally, 10 gives me another positive number when I plug it into that derivative. So the 10 is going to result in a positive solution, and that's the end. So at this point, I'm not completely done, because now I have to interpret what these things mean. So what does it mean to have a derivative that is positive? It means that the function g of x is increasing. So I'm going to put an arrow up. What does it mean to have a function derivative that is negative? That means the function itself is going to be decreasing. And then finally, again, the function g is increasing on the third interval. It's similar to the thing that happened in the first interval. So in other terms, the function increases on the first part and the last part, and it decreases in the middle part. So the question was to list the intervals on which the function g is increasing and decreasing. So let me go ahead and write them down. So we say that g of x is increasing on the interval from negative infinity to negative 3 and from 3 to infinity. And also it's decreasing in the middle interval from negative 3 to positive 3. And that's basically the end of part 2. But the question in part 3 is to list down any relative extremas, meaning tell me the maximum, minimum, if possible. And so before I go ahead and write down the answer for part 3, let's go back to this line that we have and let's interpret what negative 3 is doing. So look at what happened before and look at what happened after. The function went up, then it went down. So we went up, then we went down. That creates a mountain. So that means that negative 3 is going to have a maximum. Now, what about 3? Again, look before, look after. We went down, then we went up. That creates a low valley. So that means the positive 3 rather is going to be a minimum. So that's pretty much it. We're just going to have to record that. So we're going to say x equal to negative 3 has a maximum, and x equal to positive 3 has a minimum. Okay. So again, technically these are a relative max and a relative minimum, but you know, you don't have to use the word relative. It's automatically implied when you don't say it that the number that you're talking about is a relative maximum or relative minimum. And again, that just means that the negative 3 and positive 3 are not the highest points on the graph. The last thing I'm going to have to do here in this problem is draw the sketch of the graph. So in other terms, make a little picture that represents what I just found. And in order to do that, you know, we can draw the xy plane first of all. And here's the y-axis, here's the x-axis. The numbers that were interesting were the numbers negative 3 and positive 3. And they have some kind of a y-coordinate that I didn't find, but negative 3 was a maximum, so it's a high point, and 3 is a minimum, so it's a low point. And again, how high is it? How low is it? I really don't know. In order to find that answer, I would have to plug negative 3 and positive 3 into the original function g of x that they gave me. But I'm not going to do that right now. That's not the point of the problem. The point of the problem is to draw a sketch. And so my graph is going to look like this. It has to go up first, then it has to go down to the minimum, then it has to go up afterwards forever. And that's because of what we decided over on this line. We always start by going up, then go down, then go up. At least that's how it worked for the last couple of problems. It doesn't have to be the same for every problem out there. Okay. Now again, if you want more accuracy, you would have to find what the y-coordinate on the y-axis is. So how do you find the y-coordinate? You put 3 into the g of x. So writing g of 3 means we're putting 3 into the g of x. And again, if you want to know the y-coordinate down here, you would need to put g of negative 3. So you would put negative 3 into the function g, and you would get the y-coordinate, which tells you how low the minimum is, and the other one tells you how high the maximum is. And as you can see, the maximum is not the highest one because all these guys here are higher than it. That's why we call it a relative maximum. Similarly, this is not an absolute minimum because all these y's down here are going to be lower than it. So it is not going to be called absolute minimum. It will be called a relative minimum. And that's pretty much how the problem is going to end.